Recording.
Hi, I'm Carrie Holbert from Wacasta High School, and we're going to be doing a pre-calculus lesson today on solving equations. So the first thing I want to go through is just some basic definitions of constants, variables, and domains. So in this equation up here, we have pi times r squared, area equals pi r squared, and pi represents the constant. Pi is a number that never changes, and it has the same value of approximately 3.14159. So the pi is a constant number. The r in the equation represents the variable. A variable, we can substitute any number we want to in for it from a given set of numbers called the domain. And it's just some customary things here. Letters at the beginning of the alphabet represent constants. And letters near the end of the alphabet represent variables. So for example, in the equation, in the expression ax plus b, the a and the b will represent constant values, and the x is the variable. And one other thing about domain of a variable is a given set of numbers that can be substituted in for the variable. So in this example up here, the variable r, we can use the set of non-negative numbers to substitute in for that variable, because the radius can only be 0 or a positive number. And the domain convention that we're going to use in this class is the domain of a variable in a given expression is the set of all real number values for which the expression is defined. So here we have a little chart, and I'd like you to specify which is the variable, which is the constant or constants, and what the domain for the variable of each would be. So in this first expression, the variable is x. Constants are the 3 and the 4, and the domain would be all real numbers, which could be expressed as negative infinity to infinity. In the next expression, the variable is the t. The constants are the 1 in the numerator, the negative 1 in the denominator, and 3. And the domain here would be all real numbers, except we cannot put in the value 1 because it would make that equal to 0 in the denominator, and we cannot have negative 3 because it would make the t plus 3 in the denominator equal to 0. So you could express this as negative infinity to negative 3, negative 3 to positive 1, and then 1 to infinity. In the next expression, the variable is the y. Constants are the a, b, and the c. And the domain would be all real numbers. Because we could substitute any number in for y and get a value out. One more to go. The variable is x. The constants are 4 and 3. And we have to be careful here. It would be all real numbers for the domain, except right here, that represents 3 divided by x. So we cannot have 0 in our domain. And again, you could express this as negative infinity to 0, 0 to infinity. Okay, next. Quick review of procedures that yield equivalent equations. You can add or subtract the same quantity to both sides of an equation and produce an equivalent equation. You can multiply or divide both sides of an equation by a number as long as it is a non-zero quantity, because that would just wipe out your entire equation if it was equal to 0. And simplifying an expression on either side of an equation. So we're going to start solving some equations now. So I'd like you to try to solve this first equation up here for x. Okay, so let's see how you did in the first one. First thing I'm going to do is distribute, and it's not just the 2, but it's the -2 or -2 we're going to distribute in. So I get a -2x minus 2 for my first step. Now from here I could either combine like terms or distribute the 3 in, and I'm just going to go ahead and distribute the 3 in. But either step would be just fine. So far I have that expression. And now I'm going to try to get my x's together, so I'm going to add the 6x over. And while I'm at it, I'm going to combine these two numbers on the left side. So I get -3 equals 2, and if I combine my x's, I get a positive 5x. And I'm going to subtract over the 2. So I have -5 equals 5x, and last step, divide by the 5. So x is -1, quick check, -1 is in my domain, so that is my solution to that equation. The second one, to solve for x, we need to move the b to the other side, so ax equals c minus b, and then to solve for x means a times x, so we're going to divide over the a, so x is equal to c minus b over a. And there's no restrictions on our domain, so that is our solution. Now the last one, we're going to have to do a little more work. And on this one, before we begin the problem, I should look to see if there's any restrictions on my domain. So the first thing I think I'm going to do is I'm going to factor that expression. So I'm going to take the box method, and I'm going to put x squared, the -15, and then this quantity here has to add up to a positive 2x. So the x squared factors into x times x. The -15, I have a couple choices. I could do 5 times 3 or 1 times 15 with some positive and negatives in there. And I'm going to start with maybe 5 times 3 and see if that works. So that box would be 5x, this box would be 3x, and since this is a -15, one of those values needs to be negative. And if I look here, I need to have a positive 2x when I'm done, so I want the 5x to be positive and the 3x to be negative, so that adds up to 2x. So I'm going to go plus with the 5 and negative with the 3. So I get x, that factors into x plus 5 times x minus 3. So if I look at my denominators, there are 2 numbers that I have to take out of the domain. So I know that x cannot equal -5 or positive 3. And I'm just going to keep that in the back of my head for a minute. So now I'm going to solve for x. So I'm going to multiply each one of these terms by x plus 5, and x minus 3. So you notice it's getting a little tight in here. Okay. So this first one, the x plus 5 will cancel. 1 times x minus 3 is x minus 3. The second one, x minus 3 will cancel. So we will have 2x plus 10. And in the last one, both of the expressions cancel, so we'll have a plus 2x plus 2. So I'm going to combine like terms on the right. So 4x plus 12. I'm going to combine my x's. Move the 12. And we end up with -15 equals 3x, and divide by 3. So x is equal to negative 5. But before I go on, I need to double check what numbers are restricted from my domain. And my domain, my x cannot equal negative 5 or positive 3. So this negative 5 is an extraneous solution. So there is no real number value that would work in this equation. Sometimes extraneous solutions appear if you multiply an equation by an expression containing a variable. And we did multiply by a variable in this equation, and so it did produce an extraneous solution which does not work back in my original equation. Next, this time, not only can we solve equations for y, but we can also, if we have x and y in an equation, we can solve for x instead. So this next problem I'd like you to solve for x. But I do have a couple restrictions here where cx plus d cannot equal 0, because that would make the denominator equal to 0 over here. And cy minus a cannot equal 0, and you'll see why when we get done with the problem. So if you could solve this equation for x. Okay. There are two ways, at least, that you can start solving this equation. One way is you could cross-multiply, or, like in the previous problem, you multiply by both sides by the denominator. So I'm going to multiply by cx plus d, which will remove it from that side of the equation. So I have cxy plus dy is equal to ax plus b. Now we're trying to solve for x. So to solve for x, we need the x's to be on the same side of the equation. Anything expression or term that does not have an x on the other side of the equation. So I want to get the ax over onto the right side with the other cxy, and I'm going to move the dy onto the right-hand side. So on the left, I have cxy minus ax is equal to b minus dy. So at least my x's are on the same side of the equation now. So I'm going to factor it out. So I have x times the quantity, cy minus a, and then I'm going to divide both sides by that quantity, cy minus a. So x is equal to b minus dy divided by the quantity cy minus a. And now, you see why in the beginning of the problem we had that restriction that cy could not equal a. cy minus a could not equal 0. So there is our solution. Next, there's a very important property in pre-calculus called the zero product property, and it quite simply says if p times q is equal to 0, then either p has to be 0 or q has to be 0, or possibly both of them. So pq equals 0 if and only if p is equal to 0 or q is equal to 0 or both. So I'm going to solve a couple equations here. So again, you take this first equation, solve it for x, and then take the second equation and solve it also for x. First one, try solving it by factoring, and the second one, possibly solve it directly without factoring.